for anyone who gets kicked out or doesn't have, loses their internet access or has to leave or is absent today. So today we're going to be creating a lab report, collecting data to see how we can make a pulley more efficient. So the assignment that you're going to be completing after class today, you're going to have to choose the correct testable question for this lab. You'll notice Ms. Neville's not giving you this testable question, but we've created lab reports in the past that you can use to help guide you in the formatting. I have also not given you a hypothesis for this lab. However, we have created hypotheses together in the past, and that too will prepare you for your assignment today. We're going to collect data as a class together today, and you're going to match that data into your chart using this information for your assignment today. So let's go ahead and get started. I'm going to go to Explore Learning, our gizmo. I click the link in my folder, and this is the lab that it should have taken me to, okay? So we're going to be testing out to see what we can do to make a pulley more efficient. Can someone please remind me, what does the word efficient mean?
Easier to use.
Easier to use.
Easier to use.
Thank you. You can mute yourself now. So as we're talking about the inclined plane, the first thing that our data chart tells us to test is if I'm using one fixed pulley, that's a pulley that doesn't move, and one movable pulley with a grooved wheel that I can place in different places. If I use this pulley type, how much effort force will I need to lift my armchair? That's 900 newtons heavy. So let's get to work. So we've got the pulley type, one fixed, one movable. We're going to be lifting our armchair. Now let's drag some people over to see. Ooh, 600 newtons. So in that first box, I'm going to type in 600 newtons. Now I'm going to be testing two fixed pulleys and two movable pulleys. So let's see. We're going to add two more grooved wheels, still lifting that armchair. Let's see how much effort force we need. Only 400 newtons. Only 400 newtons. Do you notice something happening? Can anyone tell me the pattern they see so far?
The more pulleys you add, the easier it gets to lift.
Very good, Caleb. So yeah, so now let's make the prediction. How much effort force in newtons do you think it will take to lift that armchair with three fixed pulleys and three movable pulleys? Someone make an observation. 200. 102. Yep, let's see. So now let's add two more grooved wheels. Correct. Only 200 newtons were needed there. So now let's lift a heavier load. We're going to lift a bank safe. That's where we store our money, or banks store their money with really complicated passwords. They're extremely heavy, so a bank robber can't steal that safe and walk out with it, okay? This safe is double the amount of weight of the armchair. It is 1,800 newtons heavy. So let's test with our safe. Dragging our people over. goodness. 1,000 newtons. It took 1,000 newtons to move that safe from the bottom floor to the top floor of this apartment building. Now, let's try with 2 fixed and 2 movable pulleys. Only 600 newtons. Only 600 newtons. What Caleb said, that pattern that he discussed, it's happening. So let's make a prediction. How many newtons do you think will be needed to lift that safe with 3 fixed and 3 movable pulleys?
400.
Oh, yep, that's a good pattern. I think that's valid. Let's see. Good job. It only took 400 newtons there. Now we're going to lift our heaviest load. We're going to lift a piano. We're going to lift a piano that's 4,000 newtons. That's the heaviest load that we're going to lift in this experiment. So let's get to work. We're going to change the piano. Notice how Ms. Neville clicked to show the force of each rope. That's going to be helpful when you do, if you do this lab on your own. Let's see. Oh, not 3 fixed, 1 fixed, 1 movable. Okay. Whoa! More than 1,200 newtons will be needed to lift that piano. It's not going to work with less than 1,200 newtons if I'm only using 2 grooved wheels. So let's move on to 2 fixed pulleys and 2 movable. Any predictions as to how much it'll take?
800. More than 1,000 or 1,200. Probably.
Okay. We got 800 to 1,000. Oop, not 800. Not 1,000. 1,200. 1,200 newtons. Please mute yourself. Now let's add 2 more pulleys for a total of 6 pulleys on this pulley system.
$800.
Oh yeah, you saw the answer earlier. You ain't slick. 800 newtons. 800 newtons. So the question that we now need to answer, I'll give you a second to finish writing this chart down. Ms. Neville's going on at 9 o'clock.
It's 9 hours.
So the question we'll now need to answer and write down in our notebook is, what does this data tell us? Yes, what are the implications from this data? So what does this data tell us? We can make a pulley more efficient by doing what?
Adding more pulleys.
Adding more grooved wheels. Very good. So that's the answer to our question that we need to write down. We can make a pulley more efficient by adding more grooved wheels.
It's nearly done.
What?